All right, guys, I'm going to hop on here. By the way, if you're watching this set of notes, it means I'm not at school on Thursday. I don't have COVID. I wasn't exposed. I'm not in a quarantine. I have a pinched nerve in my neck that's killing me. So I'm making these just in case when I wake up on Thursday morning, it's still killing me. All right. So in our notes, we're going to be on section 3.4. It looks intimidating when you're looking at it right now. Don't worry, it's not too bad. I got you, right? I'm going to go back a page though, and I want you to go back a page as well. I did switch the notes for inverse trig, but let's go see if they stuck from yesterday. Not inverse trig, inverse derivatives, derivatives of inverse functions. So let's go take a look at what we have here. It says there's selected values of a strictly monotonic. What that means is it's always increasing or always decreasing. That's not really important right now. And its derivative. So all our information here is about g. The question is to find the derivative of g inverse at the x value of 1. So remember the algorithm I gave you for doing these yesterday? I said, let's go ahead and say, well, 1 comma, I have no clue, but this is an x value. It's the inverse's derivative at a specific x value of 1. That has to be on g inverse. I can't find the derivative there if there isn't a point there. But that means then, because the inverse functions, they swap the x's and the y's, well, that has to be on g. So I go up to my g function, and I say g of what is 1? Again, I'm looking for that y value of 1. And the answer is -1. That gets me my image points, or I think I might have called them corresponding points, but they're image points on that reflection over the line y equals x. I'm in search of g inverse's derivative at 1. Well, I can't find g inverse's derivative because that hasn't been handed to me on my table. But I can find g prime at -1. I can find the derivative on g right here. I just go to g prime of -1 and I say it's -1/5. But yesterday I told you that because, and I showed it with the square root of x and x squared, it's inverse, and I showed you how the derivatives were reciprocals, but also intuitively, a slope is change in y over change in x on a function. Now on an inverse function, x's and y's change, so it makes sense that the slopes, the derivatives, would flip or have a reciprocal effect. So this is going to be -5. We don't take the opposite sign, we simply take the reciprocal. Okay, so I would challenge you to stop this video, and there's plenty of time today to not only do the notes, but also the worksheet. I do think that you will finish in class time B group. You'll be at home, but you got to finish during the class time yesterday, so I'm trying to keep it equal. So let's go look at this guy right here. I'm going to go blue. I'm going to erase all my red, and I'm going to do it similarly. I'm looking for the inverse's derivative at x equaling -3. So I do know that the point -3 comma no clue has to be on the inverse function. So something comma -3 had to be on the original function. So I go to the original function, I see what spits out a -3 and an x value of 4 does. Those are my image points. So if -3, 4 is on G inverse, 4, -3 was on G because they swap out their X's and Y's. And again, I'm just reiterating what we did yesterday because it's always good to slide back a little bit before we slide forward, right? So I can go find G prime. I'm trying to go green here. I can find G prime at 4. All I do is go to G prime at 4. It's a -2. But the derivatives of inverse functions at image points are reciprocals. So G inverse prime at -3 will be the flip. We don't take the opposite, we just flip it. All right, so that's just a little review from yesterday, and they're usually presented tabularly. So you can expect that on your test, that I'll have you float through a table for those. So now this new stuff, what is the date today? It's you guys will be watching these on Thursday, which will be what, 10:29, I think. So the last thing we're going to do here, the next thing, there's actually a couple more things, but you actually hit the peak of the difficulty with implicit and chain. They were kind of like, all right, we started and then it was implicit and then it was chain and now yesterday's. And so it's going to sort of, it's not going to be as difficult, I don't think, because this next section just requires a good memory. Now, if you don't have a good memory, I'll try to give you some tricks for memorizing. I'm going to show you how some of them are derived because sometimes that helps in our memory. But we're going to be taking the derivatives of the inverse trig functions. Now we have to sort of go back to pre-calculus and see if we remember what it means to have inverse trig and what the notation means. So we should know that the sine of pi over 2 is the y value at pi over 2, which is 1. Sine inverse asks you to reverse that. So when it asks you what's arc sine of 1, it means what angle gave you a sine of 1, and you'd say pi halves. But just like a square undoes a square root, arc sine undoes a sine. So this is a true statement, but if I said I'm going to take the arc sine of sine pi over 2, and that'll be the arc sine, of 1. So I'm arc sining both sides of this. Arc sine undoes sine, they're inverse functions. So so pi over 2 is equal to arc sine 1. It spits the angle back. Now I'm going to do that one more time so you can see it, because I want you to understand the notation. So, excuse me. So let's do something we know the tangent of. Tangent of pi fourths is its sine over its cosine. They're both root 2 over 2. So when we do something over itself, or sine of it over cosine of it, and they're the same, this is a true statement. If you were to go to your calculator and say, what's tangent of pi fourths? It's 1. When I tan inverse, now here's the other notation for it. If I tan inverse tangent of pi fourths, then I tan inverse 1. These undo each other. So tan inverse of 1 is pi fourths. It's asking you what angle has a tangent of 1. All right, so make sure you understand what inverse trig is. That was all pre-calculus. That's something you should have already known. But I also want you to understand that arc cosine of x is the same as cosine -1 here, x, but it is not the same as cosine of x to the negative first, like that. This would be 1 over cosine, which is secant. So you have to make sure that when you read that -1 embedded in there, that doesn't mean to the -1 power, it means inverse. So that's why I prefer the words arctan. So you know it's inverse tan, not flipping tan, if that makes sense. So here's the models. You might say, what, this is a lot to memorize. They are going to be very easy, and I'm going to derive one of them in just a second so you can see why it is what it is. But when we do arc sine of a function of x, we do its derivative. But look at all of them. They all have the derivative of u on the top. So for this guy, they all have the derivative of u on the top. So on the top of this one would be a 3. So all of them have the derivative on the top. You'll notice the cofunctions, cosine, cotangent, cosecant, are all exactly the same as the non-cofunction. The only difference is the negative. So all that does is say you don't really need to know these because cofunctions are just the negative of the actual ones. So that narrows it down to 3 we actually need to memorize, because if we know these 3, arc cotangent is just negative u prime over 1 plus u squared. So if we just know those 3, furthermore, College Board doesn't test the bottom 2. So neither will I. I might throw one in an example, but you can go ahead and look. All right, so really, if you can just remember these 2, you get these 2 for free because the cofunctions just go negative, and I'm telling you, you don't have to memorize the bottom 2. So it's not as daunting of a task as it might seem. So what is going to be a good way to memorize or retain these, because we don't get to use a note card? There's a couple things. Loosely, which means without proof, just because it is what it is. A couple years ago, for these 2, because remember, once you know these 2, these are the same, just with a negative in front of it. So what I told them for these 2 is to note that u prime is always on the top. The bottoms are really similar, except arc sines is uglier than arctan. And it's uglier for 2 reasons. Because it's got the root, which arctan does not, and because it's got an uglier operator or operation. Subtraction, I think, is harder than addition. So they're basically the same, except sines is uglier. And we think we're pretty with a tan. So a couple years ago, for kids who are struggling debate, I said, are you prettier with a tan? Or like, do we tan before we go to prom, or do we think we look prettier without a tan? Now, I'm gonna be honest, at a younger age, most people look prettier with a tan. Now, when you're my age, not true. You look ugly and wrinkly. But you guys are the ones doing this, and you guys are 17, 18 years old. And we do kind of think you look a little prettier in the summer with a tan, to be honest. So the tangent one is the prettier one for 2 reasons. It does not have the root, and it has a plus. So as I talk through these, I'm going to have you think that through. It'll help you memorize. But I also like to show you where this stuff comes from. So I'm going to show you arc sine the long way. First of all, I'll show you it the short way. All right, so let's go over here. So we have a long method, which we don't want to do, but it helps because you're not memorizing something. And we have the short method, which is try to memorize that table. I said they all have u prime on the top. What's the derivative of x? With respect to x, it's just 1. For this one, they all have u prime on the top, there'd be a 3. Next, I said arc sine is uglier. I feel prettier when I have a tan for 2 reasons. It has a root and it has the subtraction. You just have to remember what's under that root for both of them. It's a 1 and a 1 and a u squared and a u squared. So it's a 1 minus u squared. So you'll notice right up here when it says arc sine x, it's 1 over the square root of 1 minus x squared. That's not a proof though, and that's not very strong, especially if your memory fails you and if you're like, or if you didn't watch the notes, or if you're like, whatever. So I want to show you why it is what it is, because I think that's got some good. If you don't understand this, that's okay. But we're going to go like this. Y equals sine inverse, also known as arc sine x. It might have said sine with the inverse embedded in it, like that. Now here's the thought process behind this. I don't know the derivative of arc sine, but I know how to undo it. Sining arc sine undoes it. Meaning if I sine the left and I apply the sine function or operation on the right, what happens is this is like natural log of e, or squaring a square root, or adding 2, subtracting 2. They're inverse operations and they wipe each other out. So what that gives me is an alternative equation that's equivalent, because I just did the same thing to both sides, just like in Algebra 1 when you're like, ooh, I'll subtract 1 from both sides. Still equal because you did the inverse operation to both sides. So I'd say sine 1 is equal to x. Now I'm going to pass the buck to geometry. The sine of y, which means y is an angle because that's what we take sines, cosines, and tangents of, is x. Remember, sine is opposite over hypotenuse. So what that means is the opposite had to have been x. The hypotenuse has to be 1. And if I were to ask you, hey, what's the sine of y? You'd say opposite over hypotenuse, x over 1, or equivalently, just x. Okay, so I've got it written now with functions that I know the derivative of. So what I'll do right now, oopsie, sorry. What I'm going to do right now, I'm going to flow into the next problem, I think. Actually, let me do this. I'm going to grab my eraser if it'll let me. I'm going to sort of shorten this up so I have a little bit more real estate to work with here. I'm going to go up here. So what I'll do now is, I do know what the derivative of sine is, and I do know what the derivative of x is. So again, I'm doing the same thing to both sides. It's a math thing you've done for years. Do the same thing to both sides. It's just now I'm taking a derivative of both sides. Earlier, I took the sine of both sides. So the question is, what's the derivative of sine? It's cosine. Keep the guts intact times the derivative of the guts. What's the derivative of x with respect to x? 1. It's the slope, or you can say dx is 1. It doesn't really matter. Remember, I'm on the y prime attack. I want to find the derivative of arc sine, or dy dx. So y prime is equal to 1 over the cosine of y. Well, what's cosine, right? Cosine in our SOHCAHTOA is adjacent over hypotenuse. So this is 1 over, and the cosine is the adjacent side, which is this one. So I actually have to go put that on there myself. But if a squared plus b squared equals c squared, then a squared would be the square root of 1 minus b squared. So that is going to be the square root of 1 minus x squared over 1. Notice I just proved that, okay? Now, had this been a u, a function of x, instead of actually x, watch how it would have changed. This would have been u. This would have been u. On my picture, this would have been u, function of x, right? This would have been du dx. It's now not 1, it's u prime, right? So it would just change it slightly. So do you need to do this? Definitely not. Do you need to understand it? I hope so. Does it matter if you don't? No, not if you can use the short method. All right. So I'm not even going to use the long method on this one because I just did it on the one up above, and I have it on the next page if you want to see it. I'm just going to try to remember. Here's what my brain does. Oh, the derivative of inverse trig. U prime is always on the top. Doesn't matter what the function is. If it's a co-function, nope, nope, then it's negative. Otherwise, we do u prime over, and we say, I feel prettier with a tan. This is not tan. So it's uglier for 2 reasons. There's a root, there's a 1, and there's a u squared. But it's uglier for 2 reasons, the root and the subtraction. So now I just need to fill in those pieces. In this scenario, u is equal to 2x. So the derivative of 2x with respect to x is 2 over the square root of 1 minus 2x quantity squared. So 4x squared, and I'm done. Now, had I done it the long way, I think I have that on the next page here. Whoops, maybe not. Had I done it the long way, I have to scroll to show you. I would have done it like that, and I would have had to little right triangle, but you're not going to do it the long way because the long way, just don't. No, understand it, but don't do it. All right, so let's walk ourselves through this one. Oh, the derivative of an inverse trig function. They all have u prime on the top, but tangent is prettier for two reasons. There's no root, and there's a plus. Whoops. That's the model. Take a look. I didn't really memorize it. I kind of am using LaRue's little tricks here. It's u prime over 1 plus u squared. What is u prime? 3 over 1 plus u squared. The answer is 3 over 1 plus 9x squared. Done. So if you can remember the models, and I'm going to repeat how we remember them. Okay, I'm going to go erase all this. They all have u prime on the top. So you always start by taking the derivative of the function inside, the derivative of the function inside, derivative, 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 derivative. The cofunctions are exactly the same as these, except the cofunctions go negative. Just like the derivative of cosine of x is negative sine x. Derivatives cofunctions go negative. We don't need to memorize the bottom two. If I give you one, you can look at it. Or if it's on a test, I'll put that on there. So really you just need to memorize these top two because cosine is the same as sine, just negative. Cotangent is the same as tangent, just negative. How do we remember them? They're almost identical, except tangent's prettier for two reasons. It doesn't have the root and it has a plus. I think that'll help you, and I think it'll serve you well for quite some time. BC tends to remember these with that. All right, so let's go down here, try two more examples, and see how it goes. So in this scenario, this is the derivative of, it doesn't say arctan, but remember this notation means the same thing. So you have to be comfortable with both of them. That doesn't mean 1 over tan. If it was that, it would have been on the outside. So that's why I like arctan better, but I don't write all books and I don't write all computer programs and I don't write all AP tests. So you need to understand that this means inverse, all right? So my u in this scenario is root x. So just know that it's arctan u. Arctan's prettier. They all have a u prime on the top. Arctan is prettier for two reasons. Because there's no root and because there's addition. So you just need to supply the u prime. So what is u prime or du dx of the square root function? It's 1/2 x to the negative 1/2, or this one is used so much, it's 1 over 2 root x. So on the top of this fraction is 1 over 2 root x. On the bottom is 1 plus u squared. And the square root of x squared, hello, they're inverse functions, is just x. We never leave complex fractions in here though. So there's two ways of you to think about this. This collapses as a product in the denominator, or think about how when we divide, we multiply by the reciprocal. So we would do 1 over 2 root x times 1 over 1 plus x. But I always like to just think it collapses as a product. So this is 1 over 2 root x times 1 plus x. Okay. Now, I'm going to do a little variance of this because it happens on your Who Killed Peppa Pig. You're like, what's that? That's the name of your worksheet. You're going to be solving a murder mystery. And I think there's a similar one on there. That might be the derivative with respect to x of sine inverse of, let's say, square root x. I'm just making this up, but it's similar, but I want to show you what happens. So they all have u prime. Let's pretend it was cosine, I think, because let's do a cofunction because we haven't done one of those yet. So go through this on the bottom. Suppose it was a cosine inverse of root x. In this scenario, u is root x, okay? So because we're doing the derivative of cosine, they all have u prime on the top, the cofunctions go negative. On the bottom, this would be the same as sines. It's uglier for two reasons. There's a root and there's a subtraction. So this is what you need to supply. And the only way that you're going to get this in your head is to practice it. So this is an assignment that you really need to do, and you really need to write this model down every time and try not to look at it. Like, try not to look at your notes. Try to actually do what I just said. Think it out. They all have u prime on the top. Cofunctions go negative. We won't be dealing with cosecant and secant. So you just need to know tangents, and you need to know sines. Because if I have sines, I have cosines, because it just goes negative. All right, so now I need to take the derivative of this guy, 1 over 2 root x, we just did it, over. On the bottom, I have the square root of 1 minus, and my u squared is still just x. But in this case, when we never leave negative exponents, it becomes 1 over 2 root x times the square root of 1 minus x. Now keep in mind the square root of 10 is equal to the square root of 2 times the square root of 5, and it works that way as well. So I like this better. So what you're going to see for your worksheet is you're not going to see that root being split apart, because I like it better as the square root of 10 instead of the square root of 2 times the square root of 5. So what's going to happen in that denominator is that x is going to get sucked back in under the root. Products for roots can be broken apart, but similarly, they can be put back together. So I just put this back together and I put this back under the root. All right, so maybe too, it's going to look like this. Square root of x minus x squared. So just be aware of what form things can be in. This would be considered the simplest form. So now we've got a doozy. Okay, so we're just going to go from 0 to 10 here in 10 minutes, because this next one is got a lot going on with it. We are taking the derivative of a function squared. This is chain rule first and foremost. Do not launch into your inverse trig stuff, because we've got a chain rule going on first. I have a function inside of a function inside of a function. The outermost function is the squaring. So when I do the derivative, I bring the 2 out front. I keep all of the guts untouched, and I drop it 1. Just like if that had been sine of 3x quantity squared last week. You would say bring the 2 out front, don't touch the sine. The derivative of sine is cosine, don't touch the peanut. The derivative of 3x is 3. Same thing here, we just have a new function in play. It's inverse trig, but it doesn't matter, it's being squared. So I bring the 2 out front, I do not touch this, and I drop it 1. Now I need to do the derivative of secant. Well, they all have, sorry, I'm going to put it over here. They all have u prime on the top. But this is one you don't need to memorize. So if you come across this one on homework or on a test, you will be able to look. Because College Board does not test you on this one. I want you to know that there is one. I want you to know how to use it, but we're not going to use memory space for it. So it says it's u prime over absolute value of u times the square root of u squared minus 1. So I'm going to just go write that on here. It's u prime over absolute value of u times the square root of u squared minus 1. I'm just going to double check, because I don't even have that one memorized, to be honest. We don't use it enough. U prime, square root of u, absolute value of u squared minus 1. So it's great. So really all you need to do is say, hey, who you? Right? Who you? So let's go do that. Who's you? It's arc secant of u. It's this green. So I just circled the u. I need to do u prime. What's the derivative of e to the 2x? E to the 2x times 2. All over the absolute value of u times the square root of u squared. E to the 2x times e to the 2x is e to the 2x plus 2x, or e to the 4x minus 1. And you're done. It looks ugly, but it's not so bad. So your assignment, I think we're done. Yep, your assignment is Actually just 9 problems, but I'm going to be very specific in what you need to show. So I'm going to go do one of the 9 for you, which leaves 8. So I'm hoping we can finish it in class. In order for me to do that though, I just need to leave for a second here this document, and I'm going to hop on your worksheet because I'm going to be pretty picky in how I grade it. So just give me 1 second. I wanted A group to finish in class yesterday. I want B group to finish in class today. So I'm not anticipating this will take very long. Just wait, I'm trying to draw up my document here on my iPad, so sometimes that takes a little bit. I thought I clicked it though. Let's try it again. Google Drive is where I have it. There, now it's spinning. So I'm going to go find your worksheet. I gave it to you guys yesterday if you were in class. If you weren't in class yesterday, you'll have to print it off at home. Or if you want to just show the work, because I get you probably, some of you, since I'm not there today, are sitting someplace and you don't have access to a printer, then go ahead, just do it on a separate sheet of paper and just number it 1, 2, 3, 4, whatever. I'm not picky about that. So just make sure you do it. Don't use this as an excuse to not do it. I'm looking for AB 20. There it is, 20. We're in chapter 3. I'm in a worksheet. And the one that you have should be worksheet 3.4. Differentiating inverse trig functions. So a murder's been committed. This is Peppa Pig. She's been found dead. We have no leads. You're going to solve the mystery, and then you're going to write me a little blurb at the end, okay, on who was the murderer. So your final answer in the final answer box down here where it says, what are the deets, meaning what are the details, your final answer is, that's number 7. At the very end of the worksheet, you're going to tell me, okay, and you're going to write me a little story, all right? You're going to say, the murderer was, let's say it was Mr. Bazal, and it took place in the swine barn. This isn't right. I have no clue. I haven't made the key yet. Mr. Bazal killed Peppa Pig with a giant slice of bacon because Peppa called the murderer a bad name. So you're going to make it into a story once you have the answers. These aren't right, by the way. But what I want to do is hop in and do one with you. Okay? We're going to go do number 6. So you'll know why the suspect behaved. So how they behaved, I mean, when they were apprehended. Let's go see. Did the suspect cry like a baby? Did he say, you'll never catch me alive, suckers? Or did he say, I didn't do that? Or did he say, whatever you do, please don't tease me, bro? It takes a lot of time to do this stuff, by the way. You're welcome. All right. Actually, I don't do it all, but let's go take a look here. Here's my function. It's a function inside of another function. So before I even deal with the fact that I have an inverse trig function, I need to do the chain rule. Okay, so I'm going to go down here and show my work because I really don't care about the story. I do, it's just kind of fun to do something different. I care about your work. So let's go take a look at how we take care of a function inside of a function. We don't touch the guts. And we say the derivative, and you're going to show your work like this. The derivative of sine is cosine. Do not touch guts. Times the derivative of the guts. Times the derivative of cosine inverse. And then you're going to write in each box the model you're using for your inverse trig, because that'll get it into your head. You're going to write it out of your workflow, but they all have u prime on the top. Cofunctions go negative. Boom. So it's going to get in your head. You're going to say, ooh, it's cosine. Sine's the uglier one for 2 reasons. There's a root and there's a minus. So you need to memorize or create sines and cosines. Sines and tangents. It gives you cosine and cotangent for free. The other 2 I didn't even put on this worksheet, okay, because you don't really need to memorize those. So all I need to do is supply the u prime. What's the derivative of t? This would be dy dt, sorry. The derivative of t is the same as the derivative of 1. It'd be 1 over the square root of 1 minus t squared. But it was a cofunction. So you have to be very careful. Now you might say, what about all this? They're inverse functions. It's like squaring a square root, adding, subtracting, multiplying, then dividing, natural logging, and then eing it or exponentiating it. They undo each other. Okay, so cosine of cosine inverse of t is just t. So he said, whatever you do, don't tase me, bro. All right, does that make sense? So for each one of these, I want some work, but somewhere like out of your work, I want, oh, this is arctan. So somewhere on this one, I want you to be somewhere, like first you have to deal with the 5 coming out front and knocking it down to the 4th, and then the derivative of the guts. So this one doesn't even have the derivative of the guts. So it's one of those other 3, right? But then remember, for tan inverse, they all have u prime. Cofunctions go negative, that one's not negative. Tangent's prettier for 2 reasons. No root, and it's addition. All right, so I'm going to stop there, and you guys have to do the other 8 as your homework, and you'll be submitting it on a Google form. Have a good one. I hope things are going well, and let's see who killed Peppa Pig.